Here's 6-41C. It starts out with a sequence. The sequence that they give you is 5, 25, 125, and 625. They don't give you that one. I put that in there myself. I put the number of the terms on top because 5 was the first number on the list. I put 1, 2, 3, 4. And then I went ahead and looked at the numbers and tried to figure out what was happening, if they were getting multiplied by something or having something added. If they would have been having something added, the same number each time, that's called arithmetic. But this one, it seems to be multiplying. 5 times 5 is 25, 25 times 5 is 125, and so on. So that's when it multiplies each time by the same number, that's called geometric. When it's geometric, it's going to kind of mirror the form of an exponential function. So in your book, I think you've learned a little bit about, remember the exponential functions? They look kind of like that. It's one of those. But this isn't a function, this is a sequence. It has terms. So the only difference between the function and the sequence is the graph. This graph is going to be a continuous graph if it's a function. If it's a sequence, it's going to look just like that, but it's going to be what we call discrete, and it's just going to be made out of dots. And when it's a function, we write it with a y and an x, and when it's a sequence, we write it with n's, usually t sub n or a sub n. We got a sub n, so instead of y, I'm saying a sub n equals 1. Oh yeah, I forgot to tell you about this. The A is the starting point. See this thing? It's the starting point, and B is the growth factor on an exponential. Okay, so when I look here, I know that it's going to be 1 because that's my starting point, or my 0th term, and then it's getting multiplied by 5. It's my multiplier. Okay? But then I can clean this up algebraically. 1 times anything is just, the anything. So I just get rid of that 1. And then here's your final answer.